Hello friends, I am Shivaji Sonone at Department of Physics, Bharatiya Jai Sangatna's Art, Science and Commerce College, Wagholi, Pune. Welcome you to the course of Principles and Applications of Physics. We'll start this course with the concept of atomic structure. Today, in this video, I will explain Rutherford alpha particle scattering experiment. In this video, we'll see the different topics: construction and working of the experiment, observations and conclusions, some concept related to the atomic nucleus, and the postulates of Rutherford atomic model with drawbacks. In 1911, Rutherford proposed a new model of atom based on alpha particle scattering experiment. In this experiment, a fast moving alpha particles of the energy 5.5 mega electron volt from the bismuth source, radioactive source, incident on the thin gold foil. The thickness of the gold foil is nearly equal to 2.1 into 10 raised to minus 7 meter. The speed of alpha particle is maximum. It is greater than 10 raised to power 4 meter. When this alpha particle get incident on the gold foil, the scattered alpha particle is observed through the rotating detector, and this detector consists of zinc sulfide screen and the microscope. This is the zinc sulfide screen with the microscope. When this alpha particle incident on the gold foil, the amount of scattering is get observed by using this rotating detector, and there is a study of number of scattering of alpha particle with scattering angle. So this is the construction of the Rutherford alpha particle scattering experiment. From this experiment, it was expected that alpha particle would be deflected by the subatomic particle in the gold atom. Why? Because the alpha particles are much heavier than the protons, but the alpha particle scattering experiment used some unexpected result. What is the observation from this experiment? The first observation, most of the alpha particle pass straight through the gold foil without any deflection. So it indicates that the most of the space of the atom is empty. Second observation from the experiment, some of the alpha particles were scattered by small angle in the order of few degree, nearly equal to 1 degree. So according to this observation, he concludes that alpha particle being positively charged and heavy compared to the electron, and it could be deflected by heavy and positive regions in the atom. It indicates that the positive charges and most of the mass of the atom are concentrated at the center, and it is known as nucleus. Third observation, a few alpha particles, it is very small, were deflected through the large angles, 90 degree or greater than 90 degree. Some of them are get rebound through the 180 degree. So it concludes that the alpha particle which travels toward the nucleus directly get retarded in backward direction, and it is due to the Coulomb's force of repulsion. And finally it comes to rest and in opposite direction due to the repulsive force. So according to this observation and conclusion, Rutherford proposed postulates of atomic structure and known as Rutherford atomic model. So first postulate, there is a positively charged center in the nucleus, in the atom known as nucleus, and whole mass of the atom is concentrated in the nucleus. Nucleus of the atom is positively charged and it is very dense and hard. The electrons, negatively charged electrons, revolve around the nucleus in a circular orbit. And according to this experiment, Rutherford suggested the size of the nucleus is about 10 raised to minus 15 meter to 10 raised to minus 14 meter. And the size of the atom is 10 raised to minus 10 meter, that is 1 angstrom. Some drawbacks of this experiment. This model is unable to explain the stability of atom. What is the stability? Stability means the negatively charged electrons and positively charged nucleus, there is a force of attraction. Then also this electron is continuously revolve in a circular orbit in place of a spiral path. Second one, it could not explain the concept of atomic spectra. When any moving charges, when any accelerated charges, it emits the radiation. According to this model, when electron is revolved in a circular orbit, this is the negatively charged, so it emits the radiation. But this model is unable to explain the emission of radiation due to the acceleration of electrons. So these are the postulates of Rutherford atomic model from alpha particle scattering experiment. We'll see some concept related to the nucleus, the composition of the nucleus. You know that the nucleus consists of two particles, proton and neutron. Proton is positively charged. The charge on the proton is 1.6 into 10 raised to minus 19 coulomb, positive charge, and its mass 1.67 into 10 raised to minus 27 kg. It is too much heavier than the electrons. Neutron is neutral, no charges on the neutron. Its mass is same, nearly same as the mass of proton. So nucleus consists of proton and neutron. Next concept, atomic number. The number of protons in the nucleus of the atom is called as atomic number. And the property of any element, it depends upon the number of proton, neutron, as well as the number of electrons revolve in a different orbits. Second concept, atomic mass number. The summation of proton and the neutron in the nucleus of the atom is called as atomic mass number. It is denoted by capital A. So capital A is equal to Z, that is the atomic number of protons, and capital N is the number of neutrons. Atomic mass unit. Atomic mass unit is the unit used to express the atomic and molecular weight. One atomic mass equal to the 1/12 of and mass of the carbon atom. and its value, 1 atomic mass unit, is equal to 1/12 of mass of the carbon atom. So its value 1.66 into 10 raised to minus 27 kg. Size of the nucleus. Size, nucleus does not have a sharp or well-defined boundary, but the size of the nucleus is given by the equation capital R is equal to R naught, the 1/3 power of atomic mass number. This R naught is the constant, its value is 1.2 into 10 raised to minus 5 meter, where A is the atomic mass number of the nucleus. So radius of the nucleus is in between 1 Fermi to 10 Fermi, means 10 raised to minus 15 meter to 10 raised to minus 14 meter. Nuclear volume. Volume is 4 by 3 pi r cube. So when you put the value of R, we get the volume is directly proportional to the atomic mass number. For the heavy element, the volume is maximum. Nucleus density. Mass of the nucleus is capital M, and it is equal to atomic mass unit into the atomic mass number. So nuclear volume is given. When you find out the density, it is the ratio of mass upon volume. The ratio of this mass and the volume is 2.29 into 10 raised to power 17 kg per meter cube. So the nucleus density, again, it depends upon the mass number. So these are the some basic concept related to the atomic nucleus. Thank you.